Hi all. So in today's class, we will be studying about the two transistor analogy. So you know that SCR is a PN-PN combination, right? So that can be divided into two transistors as that is given in the figure, PNP and NPN. So we will see what it is in detail. So last class, we have studied about the protection of SCR. So continuing from there, now we will discuss two transistor analogy. Listen very carefully. So we can see that the basic principle of SCR can be understood by a two transistor model, or we say a two transistor analogy. So it is combination of P and PN layers. So if you are bisecting, if we bisect through the dotted line, so this is the dotted line, then we will get two transistors. So PNP transistor and you have a NPN transistor. So one PNP transistor with J1 and J2 junction and another with J2 again and J3 junction. So PNP transistor is there and you have a NPN transistor. So here you can see that there is an IC1. So IC1 is the collector current of IC1 is the collector current of PNP, right? IC1 is the collector current of PNP and PNP transistor, and IC2 is the collector current of NPN transistor. So this much setup you have. So SCR is a PN-PN thyristor. So that was bisected, and we have a PNP and NP1, and you have two collector currents, IC1 and IC2. IC1 for PNP and IC2 for NPN. So now we will see the rest of the things. So this much I think is clear for you. So when a question comes, first of all, you should draw a PNP thyristor, then you should bisect it, and then you should draw it this way. So here it is the anode current, here it is the cathode current, and here it is the gate current. And we have the junctions J1, J2, and here you have junctions J2 and J3. Now coming to this figure. So this is more descriptive. So you can see here there is an anode current coming, and that is equal to the emitter current. Like emitter, so transistor will have emitter, base, and collector. So this is the PNP transistor. So this is the emitter of the from the P side. So that is emitter, and that is the anode current. And base current of T1 transistor 1 is equal to the collector current of transistor T2. That is why we have written IB1 is equal to IC2. And you can also see the collector current IC1 of T1 is equal to the base current IB2 of T2. And emitter current of T2 is equal to the cathode current. So now we will see one by one the equations. Here IC is the collector current, IE is the emitter current, and ICBO is the forward leakage current. So ICBO is the common base leakage current of collector base junction. ICBO is the common base leakage current of collector base junction, that is ICBO, or you can say forward leakage current, and alpha is the common base forward current gain, that is common base current gain. And relationship between IC and IB, collector current and base current, will be IC is equal to beta IB, where IB is the base current and beta is the common emitter forward current gain. Just understand that this much one equation is there, IC is equal to beta IB. So our main derivation starts here. So we know that basically we know one equation. I will use another color, that is IC collector current is equal to, you have studied this in last year analog electronics, S3 to be precise, alpha IE plus ICBO, where ICBO, as I told you, ICBO is the common base leakage current of the collector base junction. IC is the collector current, IE is the emitter current, and alpha, what is alpha? Alpha is the common base forward gain. Alpha is equal to common base current gain. Alpha. So now you have two collectors here, right? For one for T1 and one for T2. So for transistor T1, IC1 is equal to alpha 1 IA plus ICBO1. Okay, fine. Then for transistor T2, IC2. So you should remember alpha IE1. So IA is equal to IE1 written here. Anode current is the emitter current. And for T2, IC2 is equal to alpha into IK. IK is equal to IE2. See this figure. Plus ICBO2, and IC2 will be equal to beta 2 into IB2 from this equation again. So that's also fine. So we have equation 1 and equation 2. So from equation 1 and 2, you can write. So this is the figure. Again, I'm just making it clear. So we have 1 and 2, and also you can write IA, the anode current, is equal to IC1 plus IC2. You see here the anode current IA, that is the incoming current, is equal to outgoing current IC1, IC2, KCL, incoming to outgoing. So IA is equal to IC1 plus IC2. So now you can substitute the value of IC1 and IC2 here. So IA is equal to alpha 1 IA plus ICBO1 plus alpha 2 IK plus ICBO2. So this is equation 3 and this is equation 4. And also you can write IK is equal to IA plus IG. And also you can write IA plus IG, that is equal to IK. Same thing. So from there, you will get, substituting, you will get so IK you can substitute, IK plus IG. So IA is equal to alpha 1 IA plus ICBO1 plus alpha 2 into IA plus IG plus ICBO2. So this IA can be brought to the other side. So finally, what will be the equation? IA is equal to alpha 2 IG plus ICBO1 plus ICBO2 divided by 1 minus alpha 1 plus alpha 2, that is IA, that is the anode current. So how can you, so what you conclude from here? The same thing which we have explained now. So IA is IC1 plus IC2 KCL, again equation 3, IK is IA plus IA, that is anode current and gate current, cathode current. Then so by substituting you get IA is equal to alpha 2 IG plus ICBO1 plus ICBO2. So that is the value of anode current. So from the relation that we got, so what is the relation? I will just write it again here so that it is easy for me to explain. IA is equal to alpha 2 IG plus ICBO1 plus ICBO2 divided by 1 minus alpha 1 plus alpha 2. So from this relation, we can assure that the increasing value of alpha 1 plus alpha 2 towards infinity. So that will increase so that will become 1 by 0, which is infinity, correspond to anode current increase, right? So this value is becoming too small, that is almost 0. That means IA will increase. This decrease, this much value is decreasing, means IA will increase. Now the question is how alpha 1 plus alpha 2 is increasing. Here is the explanation using two transistor model. At the first stage, when we apply a gate current IG, it acts as the base of transistor T2. That is IB2 is equal to IG. Please check the figure. IB2 is equal to IG. So initially stage, when we apply the gate pulse, IB2 is equal to IG. Again, Hence, establishment of the emitter current give rise to alpha 2. So, alpha 2 is equal to ICB O1 by IG. So, breakover voltage by IG. And presence of gate current will generate collector current. So, you are giving the gate and they will have the collector current, right? So, so that's how transistors work. So, IC2 is equal to beta 2 into IB2, that is beta 2 into IG. This IC2 is nothing but base current IB1 of transistor T1, which will cause the flow of collector current. Therefore, IC2 is equal to beta 1 into IB1, that is equal to beta 1 into beta 2 into IG. So come again, you can see IA is equal to IC1 plus IB1. So, and hence alpha 1 increases. So, new base current of T2 is IG plus IC1 is equal to 1 plus beta 1 into beta 2 into IG. And as a result, alpha 2 also increases, and this further increases IC2, which is beta 2. So, as IB1 is in IC2, alpha 1 again increases. And this continuous positive feedback effect increases alpha 1 to alpha 2. So, there is no need of this much explanation. You can just write up to this equation. And then you can say if alpha 1 to alpha 1 plus alpha 2 increases and become close to 1, then IA will be, anode current will be increasing. That's what we need, right? More current should flow from anode to cathode. And roughly you can have an idea of based on this, because most of the things are marked in the figure. So once you know the figure, you can again explain this. Okay, so maybe this much is very, very good for you. So how bucking of the SCR can be explained by a two transistor model. As per the figure, you see the supply voltage V and the load resistance R is applied to the resistor SCR, right? Here first assume the supply voltage V is less than the breakover voltage, as is usually the case. When the gate is open, that is when switch S open, there is a base current IB equal to 0. For the base of the T2 is connected with the collector of the T1. So base of T2 is connected with the collector of T1. Therefore, no current flows in the collector of T2 and hence that of T1. So for this condition, SCR is in the off state. Fine. When switch S is closed, that is when we are giving the gate pulse, the small gate current will flow through the base of T2, which means its collector current will increase. The collector of the transistor T2 is connected with transistor T1. So the collector current of T2 is the base current of T1. Therefore, the collector current of T1 increases. But collector current of T1 is the base current of T2. This action is accumulative since an increase of current in one transistor causes an increase of current in the other transistor. As a result of this action, both transistors are driven to saturation and heavy current flows through the RL. Under such conditions, the SCR closes. So that's how SCR is becoming on based on the collector current. Okay, I hope you have understood what is two transistor analogy and how these equations are coming and how we can explain giving of gate pulse and transistor becoming on. So that's all about two transistor analogy. Thank you.